Hi everyone, my name is Derek, and today we are going to be using Scaffold-ETH 2, a starter repo that makes it really easy to deploy smart contracts and front ends from prototyping to production in just a few minutes. And our target is Metis, an L2 that's really growing right now. And if you're a developer looking for the next place to toy around or bridge a project you're already working on to a new chain, they've got a giant ecosystem development fund and they're just looking for projects to allocate it to. So I recommend you give it a shot. What is Scaffold-ETH 2? Well, if you've never heard of it, it uses modern tooling all in one place to make it much, much faster to iterate and play with your decentralized app ideas. And the beauty is it brings together a bunch of things you're probably going to use anyway, like Next.js, Tailwind, and for the smart contract stuff, hooks like WagMe, and it puts them all in one place so that you can just get straight to messing with your unique logic and not have to do any of the setup, any of the hard hat, any of the Next.js. You get it all out of the box, wired together. So let's see what it looks like. All you have to do to get started is run this CLI command. They just released this a couple months ago. And I ran it over here. You go through a couple steps. You choose between Hard Hat or Foundry. You can use either. I'm using Hard Hat for this demo. And then you hop into your editor. A quick tour of the mono repo. In the packages folder, we'll see two main folders. One for our back end. I've got Hard Hat because I chose that. And one for our front end, of course, Next.js. So to get started, we're going to have to run 3 commands. First, we're going to use Hard Hat to make a local blockchain. That's going to make it much faster and free to test with our smart contract before we start deploying it to any real networks. Then, in our second terminal, we're going to run yarn deploy. This is the Hard Hat deploy, and it's specifically deploying the contract here in this contracts folder, and it's using the logic in this deploy script. If you're not familiar with that, I recommend you check out the Hard Hat docs. They explain it very clearly. So you see we're already done. Our transaction hash is here, and our contract is deployed. But how are we going to play with it? We're going to run one more terminal and have it do yarn start for our front end. So that's it. Yarn chain, yarn deploy, yarn start, and we're off to the races. Let's open up localhost and see what this looks like. I'm going to start us off on this second tab, the debug tab. And if you've ever played around with Remix IDE or even just Etherscan or other block explorers, this should look really familiar to you. Because what it's doing is it's grabbing the ABI that got produced when we did deploy, and it's saying, what are the functions? Are they read or write? And what parameters are they expecting? So for example, this contract that you can find here in the yourcontract.sol, it's meant to be a simple but wide-ranging example. It includes things like setting strings, sending and withdrawing the native gas token, and a little bit of access control. There's like an owner. Let's use our burner wallet. We didn't even have to connect our MetaMask or anything. We just get this burner wallet right in the browser. And let's use this account to try to change the greeting from its default, building unstoppable apps, which got passed in the deploy script as an argument. And let's update that to hello, Metis. We could optionally attach some way here. I'll try that in a moment. But first, oh no, we don't have enough funds. That's what brings me over to the top right here, this being a local host blockchain. We've got a little faucet right there, and that gives us our funds. Now we are rich in our own little local economy. So let's try sending that transaction again, and it's instantly approved. That's the beauty of Hard Hat, and we see the greeting has updated. Not bad. Now let's update it one more time. We'll do a classic foo. And notice there's this counter variable that's also going up every time we call set greeting. So if I copy the address of this account that we are, this burner wallet, I can check how many times any given address has called the greeting function, and right now that count is all the way up at 2. Last thing I'll point out here is this input field. We'll see it again on the front end. Very often you're going to want to have some numerical inputs when you're building a decentralized app, and a really common pain point is going between Wei, Gwei, and ETH. So if you're not familiar with that, the difference between a Wei and an ETH is 18 zeros, 18 decimal places, and that's because blockchains don't have decimals. So they added a bunch of zeros to make it possible for us to then divide by 18 zeros and pretend we have decimals. So if you want to send 1 ETH, that's not 1, that's 1 times 10 to the 18. I am going to have to grab a little more testnet funds, and then I can send 1 whole ETH. I'll update it to foobar. And you'll notice the contract had a balance that updated. So these are some of the pieces we get in our example contract. I wanted to show off this debug contract side because, again, it's familiar if you have played with Remix or Etherscan. This is so far just as quick and, in my opinion, a little easier to use than a remix if you're trying to move really quickly through an idea, for example, at a hackathon. But this is where things go to the next level, because we can take that same contract and start working on our front end. So what I've done is I've already replaced the boilerplate that comes with the repo with a few changes you'll see with these blue and green lines. Those are the diffs from what I've added. And that's because I want to show off a few components that you get out of the box with Scaffold-ETH. So this, of course, being Next.js built on top of React, I've set up a few state variables to keep track of things as we update them on the front end. So let's walk through these components. First up, we have the address component. You can either hard code an address like I've done here, or more likely have it read some data from the blockchain and then display that. And if you're building a dApp, you're going to make an address component at some point. You're going to have to do the truncation, and if you're fancy, you'll make it hyperlink over to the block explorer. Not bad. And you'll even set up a little copy button here, because mostly people don't need to read the whole address, but if you truncate and you forget to make it possible for someone to either expand or copy, then they can't actually grab that address. So here we get the nice short view with the blockies and the copy button. Right next to that, I've got an address input field, both of these unique to Scaffold-ETH. And what you can do is you can type in an address, you can type in that one from the left, or it even resolves ENSs. I think this is really cute, especially if you choose an ENS that uses ceramic to have a profile picture. So being able to do that, it works both ways, right? I put Vitalik.eth and then it showed me the OX version, and then I pasted the OX version and it resolved that to Vitalik.eth. So that kind of flexibility just makes your UX for your users way better. Down here, we're using the real power of the Scaffold-ETH repo on the front end, these custom hooks. Use scaffold contract read and use scaffold contract write. These make it really easy to talk to the functions on your smart contract and either read its data or write to it. This is type safe. This function name right here, if I use the autocomplete, it reads from the compiled contract that we have, and it only lets us do things that actually exist. If I had accidentally typed greetings here, it would throw an error, even though this is just a string. It's pretty cool. So grabbing in this data and setting it to the greeting variable, and then setting ourselves up to be able to update the greeting with a set greeting function in a moment. That brings us down here. The greeting variable is being displayed. It's currently foobar because we just set that. And that is greeting. Of course, right here. So look at how easy that is. We just show our greeting variable that we read in from use scaffold contract read. As for updating it, I've mocked up just some examples using some of the stuff we saw in the debug contracts. Of course, if you wanted to submit this to some judges or put it in front of users, you'd want to have a better design pass. This is just meant to be a quick demo of what you can do. And by the way, since we're using Tailwind, this is fully compatible with v0.dev. If you want to speed up your development by using AI to mock up your front end, go for it. This is using Daisy UI, which is built on top of Tailwind, but because it's built on top of Tailwind, it's fully compatible with ShadCN or any other Tailwind-based component library. So that is a theme that I see across this repo, Scaffold-ETH 2. They have some opinions that get you started, but at each step, there's also the flexibility to do it however you want. Hard Hat or Foundry, whatever component library you want, and so on. If you want to dig into some of these examples and see how the React code uses these hooks, I encourage you to check it out. But for now, I'm going to show off what it looks like to deploy and then verify the contracts, and then we'll wrap it up by deploying the front end. So to get from our local Hard Hat network over to Metis, we're going to need to tweak a few things. First, we're going to need to change our Hard Hat config file here in the Hard Hat folder and make sure that it's aware of the Metis and Metis testnet networks. You can either use this repo, or if you want to do this yourself, the network details can be found in their docs. Specifically, in the deploying on Metis section, they've got a nice walkthrough if you want to do it a different way using Remix or Hard Hat. I think this Scaffold-ETH method is a little faster. Or in the verifying deployed contracts, they've got some code you can copy paste for the Hard Hat file that we're looking at here. So I just grabbed from this bottom half exactly this and put it over in my network section. I did make one change though, because the Metis docs point out that there's a community RPC endpoint being hosted by a project called Nodies. I think Nodies is super cool because they believe that RPCs are a public good, and they've got public RPCs for all of these networks and more happening every day that you can just come and grab a link for. So you could copy a free endpoint link, and you'll see that I've got that one, which is exactly the same as the one in the Nodies docs. So that's a pretty sweet thing to do. And by the way, Nodies is using a protocol called POKT under the hood. If you don't know what POKT is an RPC protocol that takes what other organizations like Alchemy are doing and seeks to decentralize it. And that makes it possible for node runners to serve up the data, and then gateway providers to access that data and shape it and massage it into whatever form makes the most sense for either your own app, if having control of your RPC layer is important to you, or you might consider running a gateway if you want to serve a certain niche in the blockchain community. They've got a Shannon upgrade coming out very soon as of the time of this recording, and that's going to make it possible for anyone to permissionlessly set up their own gateway and just tweak a few variables to change the shape of the data that you're getting from the nodes. And then you can go ahead and sell that data via RPC calls to other developers that consume it. A pretty cool project and pretty innovative. I'm not aware of anything else in the DPIN space, the decentralized physical infrastructure narrative that's pretty hot right now. I'm not aware of anyone else decentralizing the RPC layer. So I like POKT because the idea of decentralization, that like high uptime and the guarantee that your data is going to be there because it's decentralized across a bunch of different providers. And then you combine that with the fact that it's cheap and fast. It's like, well, why not? So Nodies is a gateway running on top of POKT, and Metis and I are both fans. So what I've done is I made sure to use the Nodies link over here in my setup. The other thing that I tweaked is down here. This is for 2 steps from now. We're going to be running hardhat verify to verify the contract after we deploy it. So let's get into it. How does one deploy using Scaffold-ETH? If you're not familiar with hardhat, we're going to be running yarn deploy, and this time we can either update the default network. In this case, we could set it to something like Metis or Metis Sepolia. I always mess this up, careful. Metis mainnet is called Andromeda, so don't set it to Metis, set it to Andromeda in this case. Or you can pass it in as a flag. Now I want to make sure I'm getting my syntax right here. Well, let's just YOLO. So nothing to compile, and we've deployed it. There's something really magical happening under the hood here that I'm going to explain. Notice that when we're doing most of these things, I haven't even set up any environment variables. So where are the Etherscan API keys? Where's the private key for whoever's doing this deployment? If you're a developer, you probably have the fear in your heart of using a private key that has funds attached to it in the context of your repo, especially if you're publishing it. There's ways to get around it and be safe, but wouldn't it be nice if you could just avoid that problem altogether? Well, you can in Scaffold-ETH by running yarn generate. Yarn generate will create a private key local to the repo, and it'll use that for things like deploying. If I've already run it, so I'm just going to run a complementary command, yarn account, that shows the public address, gives you a QR code so that you can just whip out your phone and send some funds to it with your MetaMask wallet if you have something like that. And it also checks the balance of the private key account for the repo across all the networks that it's aware of. So you'll notice up here that I've already set it up to have some funds on Metis testnet and mainnet. All I had to do was copy this and then use my wallet to send some funds over. Super easy and very safe. Okay, now that we've got that and we've deployed, let's check out our contract. So here's our contract right on the Metis Explorer, and this is live on Metis mainnet. You could, of course, mess around with testnet if you like. They've got a faucet there, but I went straight to mainnet because it only cost a few cents to deploy. Now, because I already ran through this, it's verified, but I'm still going to show you the syntax for that. We're going to be using hardhat verify, not to be confused with Etherscan verify. Both of them work, and both of them are available in Scaffold-ETH 2. But the Metis docs recommend hardhat verify. It's newer, and the Scaffold-ETH docs over here in the shipping your app section show how you can do either in the context of right after you deploy when you go to verify. So I'm using this hardhat verify syntax. I'm passing in the address of the contract and any arguments inside. Specifically, when we go to deploy this contract, in the constructor, there is an argument during setup, and it's the deployer. It's like the message.sender. That's the default owner of the contract, the only account that is allowed to withdraw any funds that are deposited to it. And so the OX45E that you see here is that same public address for the account within our repo that is deploying it. It's the deployer address. So I have to pass that in here as a string, as the setup argument, so that as I go to verify, it has all the information it needs to confirm that, yes, this is the contract and this is how it's set up. Run that command, and over on the contract side, It's already been verified, and that means that you get all the nice things. First of all, your code's right here. It's open source. People can come check it out, make sure you're not going to rug them. And then you've got your read and write functions. That's all well and good, but I promised that we were going to deploy the smart contract and the front end. So there's only one more step. Let's edit one line in our scaffold config. I'll show you where that is. Over in the Next.js repo, we've got our scaffold config file. And there's one really important line here, target networks. And right now it's set to chains.hardhat. This chains is an array coming from VM, the same team that made WAGME. They made VM to replace like Ethers.js and Web3.js. And it's just grabbing hardhat. This is something that you can use autocomplete on and see all the different networks they have. And in our case, we're going to be going for Metis. That's mainnet Andromeda. If you update this and hit save, literally change that one variable, then the front end that we're working with is going to change from the hardhat network to the Metis network. I think that's pretty slick to be able to just come in and use a type-safe autocomplete to have your front end actually working. Really cool. Now, by default, there's this variable down here, only local burner wallet. It makes it so that when you go to any testnet or mainnet for your front end, that it disables this burner wallet. I set that to false for now so that we can keep using this account and check out that it does in fact still work. This is the same front end page and the same debug contracts, but now they're referring to the same contract address we just deployed to Andromeda. It just works. You could sit here and just change the target networks and deploy your smart contract to 11 different chains and deploy 11 different versions of your front end, or better yet, one version of your front end that can toggle between all these networks. And you could have your app live in a dozen places with just like 15 more minutes of effort. I think that's pretty powerful. I mean, if you want to compete with something like sushi, that's how you do it. So we changed that one line, updated our target network, and now our front end is on Metis, just like our smart contract. We already deployed the smart contract, which means the only thing left to do is deploy the front end. Go through a couple commands. Let's call this one Metis demo. And Vercel is going to do its thing. I'm telling you, this is just such a good developer experience, especially once you're used to the rhythm of getting in there. The setup is quick. So much of this, the initialization is already done for you. All the hard hat stuff, for example, or weaving together WAGME and setting up these custom hooks. There's the custom components like the address and address input and integer input and stuff that I showed on the front. It's just nice. It just makes it so you can sit down and focus on prototyping your smart contract and designing a front end that looks good and is easy to wire up to talk to the smart contract. That's where you should be spending your time. All right, finished our build, and let's go check it out. Beautiful. And I didn't even mention dark mode. How nice is that? So there you go. Prototyping to production, smart contracts and front end with modern stack and almost no setup in just a few minutes. I think this is a really powerful tool, and whether you're trying to deploy to Metis or other chains, this is a really fast way to do it. It really shows the level of thoughtfulness that Scaffold-ETH 2 team has put into this, that they even give you default keys. You can override these, of course, before you go into production with something that makes more sense, especially if you're going to get some traffic. But the fact that you don't even have to think about an Etherscan API key or even a private key for deploying the contracts is something I haven't found anywhere else. So check them out. And again, I highly recommend you check out POKT for your RPC needs. If you want free RPC links, you can go ahead and grab them from Nodies.app for a bunch of different chains. Good luck, and I can't wait to see what you build on Metis.